So later that summer, Jan LeCun invites Jeff Hinton in. Jeff Hinton is really excited at that time to teach us all about his new research in capsule networks, and he's pumped about it, right? So he's like, he shows all the, these are like top researchers, like Tomas Mikolov is there, Ilan Botois is there, like really, really top-notch researchers are all there, and he shows them all, look, he's like one of the greatest minds in ML at the time and still now in some ways, and he says to everyone, like, look, I have a big result. Jan LeCun's MNIST data set isn't perfect like everyone thought. It actually has an error in it, and he checked it 100 times, but I could find an error with capsule networks. So he shows everyone this, and people are all laughing, and they're like, Jan LeCun, you screwed up, and he's like, they're being like playful about it. This motivated me. So when I saw that, I was like, well, if there's one, maybe there are thousands. And so I ended up building a new subfield of machine learning over the next 4 years. That was my PhD, called confident learning. Like if you wanted to interact with Walmart, like you can still go to a storefront, but you also interact with their website, and you do mentally think you're interacting with Walmart when you're on walmart.com.
Totally.
So it's going to happen. It's going to be agents. That's a real thing. And you've probably heard that before, but it's also something I fundamentally believe, where some people are sort of shaky, and I feel like 100%.
Absolutely.
Welcome to govai.fm, your no-nonsense guide to AI in the public sector. Connect with peers and learn from real successes, failures, and lessons from the trenches.
Joining me today is Dr. Curtis Northcutt, founder and CEO of Cleanlab's AI. Now, after completing his PhD at MIT, Curtis teamed up with his fellow MIT PhDs to create Cleanlab, the infrastructure layer that makes AI dependable. Their mission? To help agencies like ours take the AI use case from a neat POC to a 95% plus production system that delivers value. Cleanlab powers trust scores at more than 100 Fortune 500 organizations. And I'm really excited to have Curtis here. Hey, Curtis.
Hey, I'm excited to chat with you, Garesh.
Okay, awesome. So what I think one of the things that I'm fascinated by is just you. What we can do is maybe you can just tell your story, right? Like we would love to know your story, give some background on how you came all the way to what you're doing right now.
Awesome. I'll try to do the short version.
Okay.
I'm from rural Kentucky. I care deeply about people who are born with less, people who are born from cities or from areas that don't have the resources that cities have. I care deeply about that child who really wished that they could do more, but they weren't able to because they didn't have the resources. And I felt very much like I was that child for most of the first half of my life.
I see.
That motivation has driven pretty much everything I've done. So the first 18 years of my life was a lot of pain, poverty. Family struggled to get along, and I bounced back and forth between homes. I did not sleep in the same bed 2 nights in a row for 4 years, from the age of 10 to 14, and had to work with a judge to separate between my parents and get in the right home. And so I didn't have a very easy life growing up, and at least that's the way I thought of it. I'm sure compared to many people, it was a great life. But at least for myself, I felt a desperate need to create opportunity, to be able to have access to resources, to be able to do great things. And I didn't want anyone else to have to experience some of the things I experienced. So over time, technology was growing. I was born in the late 1980s, early 1990s range, and the internet had just come out, and we got our first computer when I was like 10 years old. And I realized like this is a pretty amazing thing because I can search the internet and educate myself, and I can do. I'm from rural Kentucky, so it's not like there's MIT there. And my father was a mailman, and my mom works in a call center still today. And so I just didn't have a background where I could have access to resources or really access to do much of anything that I wanted to do, which was I wanted to change the world. I wanted to make a better place, and I wanted to invent. I wanted to explore what was possible. And I felt very limited. So this is kind of the person that manifested over those 18 years. Basically imagine someone who wants to run a marathon but is in a cast, unable to move their legs. And this has created a tremendous fuel in me that I still have today in my mid-30s. What ultimately ended up happening was I went to Vanderbilt, which was sort of the best school that I could go to at that time. And technology continued to grow. I tried every engineering, STEM, science. I studied physics and chemistry and math and anything I could to try to enable myself and use the educational opportunity that America provides to work myself up the ladder of opportunity. And eventually I stumbled on some computer science in like a mechanical engineering course, and I was good at it. I was very good at it. And it was fun. And I knew I found something kind of special because not only was I good at it, but it was also fun. And it was also extremely, extremely useful to solve the problems that I cared the most about, which is empowering people. About that time, AI started to grow a little bit, and we started to see like convolutional neural networks. And by 2016, I went to MIT in 2013. And then by 2016, I was working with Jan LeCun in convolutional neural networks and reinforcement learning at Facebook AI Research in the New York office. And that trend just kept kind of exploding from there. That was pretty fundamental. From there, I worked at Amazon Research while doing my PhD at MIT. And then I went to Oculus for 2.5 years while doing my PhD, and then Google Research, and then started a couple other smaller startups. And then eventually I realized that there was one singular thing that everything I had done in the last 8 years sort of all revolved around. And that was that whenever we tried to use machine learning to solve the most critical problems of society, humanity, and especially empowerment for people, it always ran into the same issue. And the issue was always that it didn't work well enough. The outputs were never reliable enough. And we've seen this across the board. Like the game of AI is just go from accuracy 80% to 85%. And you can see this historically for 30 years. It's always about just improving the bar. But I never saw like a fundamental framework or product that could take an existing system and just get you over the bar, that you could use it. And so I'll tie all the pieces together on this, in some ways I still think of me as that guy from rural Kentucky just trying to access the resources available to make the world a little bit better, ideally, make more opportunity. But when I tried, for example, to build cheating detection for MIT, so I owned cheating detection for all of MIT and Harvard for about 4 years from 2013 to 2016, and I used machine learning, it didn't work. And when I tried to do a problem with Google, which was to make their Hey Google and OK Google devices all wake up for 50 different languages accurately, it was nowhere near accurate enough. And so there's a lot to unpack here, but all of these pieces all led me to the singular realization that what was critically needed in the industry is a way to be able to know when the system is going to make a mistake, to be able to prevent, control, and improve when that happens. And do we actually have any products at the industry scale that can work in production to solve this for arbitrary machine learning models? And the answer has been no for the past 3 decades. And I'm here to change that. I've been working very hard on changing that for about half a decade.
Wow. What a fascinating story. Like so many aspects to it. Like, wow, feels like we can make a movie on you soon.
We'll make it together.
Okay, so one of the things that resonated with me is what you're talking about. Like talent is evenly, I heard it somewhere. Talent is generally evenly distributed, but opportunities are not. Making like maybe technology, maybe AI can help make those opportunities available to everyone too. And it's fascinating that is something that is so core to what you want to do. So many things. Like I didn't realize you worked with Jan LeCun with FAIR and everything. But yeah, any stories with any of these, like Google, Amazon, Facebook, like that you wanted to share?
I have tons of stories. Yeah, so I'll tell you a story about Jeff Hinton and Jan LeCun in 2016.
Okay.
Jeff Hinton came to visit. So Jeff and Jan are friends. I am not anywhere near as close to them as they are to each other. In fact, it's not even worth comparing. I was an intern in 2016. I want to be very clear. A PhD research intern, but an intern with Jan. And I reported to Jan, but my main manager was Elon Barreau, who was an incredible PhD researcher at FAIR and just a really kind and smart and intelligent person. But I got to work with some of the leading research scientists. So some of the people who were there, like the person I sat by was Sumit Chintala, who wrote PyTorch. Yes. And the whole summer, by the way, I saw this. He's a great guy. He's really fun. Very good personality. I'm sitting by him, like doing what I was building at Facebook was their basically the comment recommendation. So I was building the recommendation engine of like, what do you recommend in a Facebook comment to sort of like maximize diversity, but also likelihood of people retending and using. But also like, how do you get a diverse set of opinions? So it's not just, anyway, so I'm working on that. I'm pretty focused on that problem. There's this, really sharp, hardworking guy who's kind of like fun, and next to me, who's just hacking away the whole time. And the funny thing is, there was always a happy hour, and he would always go and like grab drinks, and he'd be gone for like a couple hours. And I always thought he took off early, but then I started working later when I was at Fair, and I was there sometimes till like 1, 2 a.m. And the only guy who was there was Sumit, and he was next to me, and he was just hacking away. And I remember I had a meeting with him one time, and I was like, dude, TensorFlow is so successful compared to Torch. At the time, Torch was on Lua, because Lua is like a video gaming World of Warcraft language, and like no one's using that for deep learning. Like, have you thought about potentially taking Torch and putting it on Python? And he just looks at me and he's like, just wait. He's like laughing, And then like, of course, 6 months later, PyTorch comes out. And that was probably the biggest game-changing thing for deep learning in terms of like
absolutely
consumer ready. So that's one. And then the other one, I'll bring it back to the Jeff Hinton, Jan LeCun story. So later that summer, Jan LeCun invites Jeff Hinton in, and Jeff Hinton is really excited at that time to teach us all about his new research in capsule networks. If you were familiar.
Yeah, he used to talk a lot about that.
Yeah, it's because it's academically, it's an extremely interesting thing. And if you look at the benchmarks, like what you can do by breaking up a network into sort of almost the theory of mind, like the various components that can each manage and learn. He was sort of doing like multi-agents before transformers, like multi-network, but all within a single network. So he was sort of training the community versus just, but the thing is the way he's a very brilliant person, one of the most intelligent people I've ever met. And the way that he interacted and the way that he shared that research was so theoretical and academic in some ways. I think it didn't quite hit with people just how incredible capsule networks could be. And the packages that were released were very hard to use. And anytime you tried to run like GitHub code that was, that it was running these things, it was always like a gobbledygook of code. And it just it didn't feel like PyTorch where you just, So anyway, I think he kept pushing it because it was smart, but it wasn't taking off. Anyway, so he comes in, he does a whole hour on capsule networks, and people are kind of interested, but it wasn't. And then he goes, all right, let me tell you something I'm really excited about. And he pulls out Jan LeCun's MNIST dataset. And he shows that there's a number in there that's like a 3 that was actually labeled a 5. And he shows using capsule networks that he's able to find that one label error in all of MNIST dataset, of all of Jan LeCun's MNIST dataset. And he's pumped about it, right? So he's like, he shows all the, these are like top researchers, like Tomas Mikolov is there, Ilan Botois is there. Like really, really top-notch researchers are all there. And he shows them all, look, he's like one of the greatest minds in ML at the time and still now in some ways. And he says to everyone, like, look, I have a big result. Jan LeCun's MNIST data set isn't perfect like everyone thought. It actually has an error in it. And he checked it 100 times, but I could find an error with capsule networks. So he shows everyone this, and people are all laughing, and they're like, Jan LeCun, you screwed up. And he's like, they're being like playful about it. Well, I ended up building, this motivated me. So when I saw that, I was like, well, if there's one, maybe there are thousands. And so I ended up building a new subfield of machine learning over the next 4 years. That was my PhD, called confident learning, where I was able to build, and anyone can use confident learning. You can just search it on Google. And it's like really easy to use. There's an open source package that will let you do that with Cleanlab. And you can now find all of the errors in any arbitrary machine learning data set. And it turned out that MNIST doesn't just have the one error that Jeff Hinton found. It has thousands of errors, and they're all now public and available online using Cleanlab.
Oh my God, that's fascinating. Wow, you have so many stories. Yeah, so maybe you can take us into like how did all of this get into founding Cleanlab, and how did your co-founders come together?
Yeah, of course. So we did a paper first. It's called Pervasive Label Errors Destabilize Test Set Benchmarks. And we took Cleanlab, the confident learning approach, and this was pre-company. We took what was called Cleanlab, the open source, in 2018 or so. And initially, before I knew Anish from MIT, he was sort of the hallmark MIT systems person, extremely, extremely talented and competent, very well known across MIT. And then Jonas was known as like the ML person.
I see.
And he was less known because he's an incredibly humble and non-advertising personality. So he like never tells anyone how capable he is. And, you've got to meet with him and work with him. And Jonas Mueller, he's a very understated person. And he works a lot. So like you might meet like a tired, sort of grumbly guy, but like the reality is he's probably the most capable ML person who I have a close relationship with. And I spent 8 years at MIT. And so the two of them were people who I just deeply admired when I was a grad student and got to know through that deep admiration and became friends with. We were mostly hiking friends, but then we started to work on some projects because we all ended up touching various aspects of auto ML, like making ML just work and be high accuracy. And then the data layer. So like adversarial examples is what Anish worked on. The data errors is what I worked on, finding them automatically with AI. Auto ML and like auto regressive improvement of machine learning models is what Jonas worked on. And the three of us, initially on my own, I started exploring the errors in Jan LeCun's dataset, and then ImageNet, and then Amazon Research's datasets, especially like the Amazon reviews. And after I had 3 or 4 under my belt, I realized, okay, this works. Like we can actually reliably and with provable guarantees find errors in every major ML dataset. So I reached out, I met Anish, I caught up with him at ICML. He had just won Best Paper Award at ICML in Sweden in 2018. I'm not sure. It's sometime around then. And we're sitting in Sweden, and I just say to Anish, I'm like, look, you're showing how all of AI is broken on these sort of on the robustness to adversarial examples. Are you interested in showing how all of AI is broken, period? And he was like, well, that's enticing. What do you mean? And I was like, well, it turns out that all the test sets that we are benchmarking all of AI on, so like every major test set, MNIST, ImageNet, the text ones, Amazon reviews, NLP benchmarks, tabular data sets, they're all broken. And they all have tons of errors in them, and no one knows how bad. And it may just turn out that our benchmarks are all wrong. And so he got very interested, and he brought a tremendous improvement to the set of skills that we brought to the research. He's a very insightful person. He helped me with a few of the proofs, so I had a lot of theoretical work I had done, and he found some insights to push that even further. And then he helped tremendously on the system side. And we got to a point where me and Anish together had discovered about 10 different critical core test sets that the whole field had benchmarked on were all wrong, and how wrong they were. And then we got stuck. And we looked at each other and we were like, what's the point of this for the field of machine learning? And so I told Anish, well, let's talk to the smartest guy I know in ML. And so we met with Jonas, and Jonas was like, I think the issue here is that there are models that you can swap out, and actually the benchmarks would be totally different, and nobody knows. And so Jonas took it to much closer focus on the actual benchmarks that the ML community was doing. And we were able to prove that all of these errors and test sets were actually undermining the value of all the benchmarking that had been done for like the last 20 years. And ultimately, that's how we realized that we had solved a problem that was critical, fundamental, and unique. And then a bunch of businesses reached out and a bunch of companies reached out. Can we buy the product? And the company was pretty natural after that.
Wow, this is so fascinating. Like what you're talking about is pre-LLM days, right? Like, so you're talking about identifying like the data sets which were like just traditional machine learning models and deep learning models and the ones that we are using for benchmark. But now a lot of companies are working on LLMs just because they are faster, right? Like you'll take 3 to 6 months to have a deep learning machine learning solution in production, but with an LLM solution you can at least create like POCs and pilots in weeks, right? Like so a lot of our audience is interested in the LLMs and RAGs, and they have heard a lot of horror stories about hallucination. And maybe we can come to that, and maybe you can explain why do LLMs get it like hallucinate, or generally why were those machine learning models that you're talking about getting things wrong?
Kept talking about traditional machine learning since everything is about agents and AI and RAG. And the young person says to the older person, like classical ML, like I know, a bunch of stuff about it, but like who cares, because everything's about agents now, and have you seen ChatGPT and all this stuff? And the older person says, of course I have. I work on those things all the time, but I talk about classical ML because that's the fundamental core work that agents are built on top of. And I've spent 40 years in this field, and I understand how these things actually work at a very core and fundamental level. And I use that research in order to make the best agents, anyone has ever seen. And I resonated deeply with this conversation. So I talk a lot about classical ML when you ask about my background, but the last 3 years I've done nothing but work on agents, and specifically the problem of how do we make agents and RAG-based systems, fundamentally LLM and transformer-based systems, as accurate and reliable as possible. And some subset of that is machine learning and AI work, and some subset of that is actually just really good software. And so just to share a bit about like how do we take the sort of label errors ideologies and transition them, the fundamental thing that a LLM is doing is sampling a distribution over a bunch of logits to predict what the next word is going to be based on a bunch of neural network weights that have sort of pre-programmed, the new, as Karpathy puts it, software 3.0, which basically is telling you like how to generate a particular type of output for a given input. And if you think about an LLM that way, you can start to recognize that actually every word being produced is not so dissimilar to like a label of a data point. Like ultimately you're producing a word and that word is a label. It's one of 50,000 potential labels, and you're selecting a label for a given input, which is the data point. And you can, if you think deeply about the problem, you'll start to realize that it's not so different to say that you're doing text classification, but you're doing it over and over and over to produce a new output. And so when you think that way, you can very quickly get to the realization that you can actually estimate the probability of every single word coming out being likely or not. And you can do it in rigorous ways, not just like the probability and multiply them like a joint, you might just do a joint probability and say, hey, normalize it, call it perplexity and move on.
Correct.
But you can actually do a lot smarter things. For example, you can say, well, what was the token that was actually produced by the LLM? What was the probability distribution over those tokens? If it's not just taking the argmax and it's actually sampling, then what was the distribution, which is how these things work? What was the distribution over probabilities? And is the token that was produced, if you look at the whole entire sentence as a whole, what was the joint probability of that sentence and the individual probabilities of the sentence? And you can actually do a lot of fundamental things to estimate the uncertainty of that sentence. So that was the initial step that we took. And then from there, we started adding the other stuff that's really simple. Like we added the, LM as a judge and like all the simple ideas, but those are nice. But when you combine them with fundamental and mathematical probabilistic approaches, you get a much stronger estimate of just how likely it is that LLM is saying the truth or not, or producing a label. Let's just for simplicity, let's just say a label that is of extremely high quality. And that's the fundamental basis of the shift that we made. That only got us about halfway. So the other half, and then I'll sort of pause, is it's a tremendous amount of software to actually control a system. And I think in the hype and excitement of like, wow, these things generate meaningful things, we forget that in the real world, we impose control everywhere. That's why we have laws and police and infrastructure and railway signs. And that's why you walk a certain place in the road. And in America, you walk on the right side. And in China, you walk on the left side. Everywhere throughout society and human intelligent behavior, we enforce and instrict control. And there's so many movies about it. It's the basis of like The Matrix and the basis of all these fundamental and philosophical ideas. And as human beings, we want some existential creativity. So we're always saying like, screw the control, but like fundamentally we depend on the control, and it's the very meat of what allows us to be a productive society. I think what people are missing with these agents is like a tremendous amount of software that actually controls rigorously the output is needed. And it's not all going to be like magical AI 0 to 1 trustworthiness scores. A lot of it is like, I need to have a human answer here. I need to get this escalated. I need to just basically block outputs like that. I need a way to very quickly check for substrings. Like, did this say a racist statement? Did it say a biased statement? Does it mention race at all? Like, these are simple if statements and guardrails, but it's a tremendous suite of software that's necessary to do that. And we took a opinionated stance, like, well, let's just build the software too. So we combined a bunch of fundamental, mathematical approaches, which is interesting and got us pretty far in terms of being the best company in the world for estimating uncertainty. But then what I think has really made us a business is leaning into understanding like there's a real business need to be able to control this free-spirited generational output that's coming out of LLMs to be able to make it actually do what you need it to do to be productive and effective for work.
That's beautiful. So combining the theoretical approach with the engineering solutions, if you will. Like beginning of Google, they tell the stories about a lot of like that page rank is one piece, but a lot of engineering solutions like added up together to make up what made the difference. Something similar to that, where the theoretical is important and that forms the base, but then doing all these 20, 30, 50 other things around it based on your deep fundamental knowledge of like machine learning and understanding how these outputs might get wrong and what all things we can do. And a lot of these individual solutions might be simple things, but you know where to add them and how to build an end-to-end pipeline with them. That's pretty cool. Okay, so yeah, I think you answered a bunch of questions about why do these LLMs, like why can they keep, because they are just pulling from a probability distribution, and if we know the details of this probability distribution earlier, OpenAI used to even share that, right? Like with each token or something, like they used to have these distributions, like they would give, like these days not many people are using it, but earlier people were using those general, can you give an intuition of the broad landscape of some of the strategies that people use for solving these problems? You kind of mentioned a few already, but just making a list of those for people. Like one was like sampling, one was like a third-party judge agent, like you mentioned a few, so maybe we'll just state them for our audience.
Hours writing random ad hoc Jupyter notebooks and like Pythonic API software. Now they spend only 1,000 hours, but it's all written by, Claude Code and Cursor.
Yeah.
And that's even less control. And it's great for getting something spun up quickly. It's very, very poor for like deep multi-million-dollar deal customer support, or like at scale thousands of citizens or customers, making sure that you're handling all of the different conversations well. But in terms of just like if you're a small startup and you're just trying to get something up and running, and like you're working with like a sub $5 million seed raise and you're just trying to get something going, like it's not a bad idea to just play around a little bit and see what you can do. So that's probably step one, is like people will write a bunch of if statements in Python, just like checking all the outputs. And then step two that most people try is LM as a judge. And that's a very simple at that. But
yeah, I've tried that and it's just meaningless numbers. Like give me percentage, like yeah, totally.
It's just not what LLMs are designed for, and it's not how they're trained, and it's, nothing about the transformer network suggests it should be able to do that well. So then what some people have tried is just doing a perplexity on the probabilities. So basically multiply all the argmaxes on all the logits coming out to give you a score of how confident the answer is. And that's probably one of the worst methods on its own. Just there's a package called geval that you can try, and I highly recommend that you don't use that in practice. That's a this has been benchmarked by many companies, not just us. And then there's some other methods that actually work really well, but they're not affordable. So for example, you can do consensus estimation. And this one it's the most straightforward and obvious once it clicks. So all you have to do is you have an LLM and you have something you want to ask it and you want to see what the answer is. But instead of asking it one time and seeing the answer one time, you ask it like say 64 times and you see how many times does the most common answer occur. And if the most common answer occurs very frequently, you say it's a very high trustworthy answer.
Yeah.
Exactly.
Yeah, so you get your own confidence rating based on the number. And also when you're asking the questions, add some variability to the way you ask the questions to be even more robust, I guess.
That's right. You can, the nice thing about this approach is not only do you get what the best answer is, which tends to be on average better than if you just run it once, by the way. So that's a good thing. You're going to pay 64 times as much. So that's the reason why no one does it. But it does something else really valuable. Say that you ran it 64 times and the most common answer occurred 60 times. Well, now you know that the trustworthiness of that answer is 60 divided by 64. So it's very easy to compute.
Yeah.
But the downside, of course, is that you now have paid 64 times as much, which nobody wants to do. So part of the software that we've also written at Cleanlab is a way that we can do this on much smaller models that are distributed and embedded on cheap GPUs that we all run, that allows us to compute that for like 25 cents on the dollar instead of $64 on the dollar.
Wow.
So it's like significant magnitudes cheaper than anything else out there.
That gives a much better intuition, like even for me, on what you're doing and the value that having an infrastructure that some third-party company has built that does this, the value, it becomes much clearer to me. And you're right, like, what if you have those 64, and then if you get like 60 by 64, that's a much better number of confidence than asking an LLM like, how confident are you of this answer? So that it totally resonates with me. So that's super cool. Any stories in business? Like you mentioned some of the stories in your research time. Any stories in business where it helped with some hallucinations or some label errors in deployments, some of the companies that you worked with?
Yeah, that's something you can learn a lot about online. But in my position, I, try not to directly state that,
Of course.
given the things that I've signed. But you can look that up online and learn more. But I'll just say at a very high level, like, we work with some of the biggest technology companies globally ever. We also work with some of the biggest financial institutions ever. One of them, for example, I'm certain everyone on this podcast will have heard of if they're based in the United States, but probably globally. And I'll share a few really interesting examples. One really neat example is there was a device that, I have to be thoughtful about how to word this. It's a device that's used by a lot of people. I can't say how many because that could give it away. But it's an AI thing, and it's in the general tech sector. And everybody's probably heard of it, whether they've used it or not. And that device in particular was recording data when it shouldn't be. And it just so happened that the way that the AI worked and the voice assistant and all that stuff, it would kind of wake up to like some of the funnier sounds that are made. Like, for example, bedroom noises, when you're having private time. And so this was very critical to solve. So that was an example of a problem where we worked pretty closely to solve that and make sure that the accuracy was like extremely high in production. So it wouldn't record like in bedroom noises.
Such an important, such an important and public problem. Totally.
Yeah. That one was wild. And then I think another one that's really interesting is there's some really interesting companies that are coming out that take a different stance than we do in customer support. So like, for example, we're working together on a customer support focus where it's like citizen support, but it's still like very similar. But there are some companies out there that will sell like the end-to-end thing. They charge out the wazoo. It'll be like $3 million, $5 million bucks, but they'll basically just build the whole thing for you. But then I learned a lot. So one thing I've learned a lot about the customers of those companies is that when I met with those customers and they were doing POCs with those companies, they shared with me that their biggest issue and why they wouldn't move forward is, while it was awesome to get something up and running for the next 6 months, they ultimately realized that their engineering team was immediately handcuffed because now their entire customer support suite was owned by a third party. And then their marketing and branding agency was also handcuffed because the only way that they could control their own brand was to work with the consulting of the third party who now owns their customer support agents completely. And so it's created actually a really interesting market dynamic where we sit in a nice little spot because we don't own anything. We just provide the infrastructure to make it work. And you get to own your entire brand, but we support you so that you can build it in like a few months instead of these multi-year cycles, in some cases in just weeks. So that's been a big lesson in the market, is that there is space for us to actually potentially do the bigger opportunity, which is, you're a company that wants to build customer support. You're down to buy something, but you need to own your brand and not like destroy your engineering capabilities. And the only way to do that is to buy up enough of the parts, but still have ownership of the actual system. And the field is just now getting to a place where like Cleanlab is selling like the accuracy, reliability, safety, control parts. And then there's other companies that sell like the embeddings, retrieval, RAG parts. Thing.
Yeah.
And so that's been a really interesting finding of just kind of why people didn't like some of the stuff that I thought would actually be really successful.
That's true. And this happens in many technology trends, whether, which one wins out, like whether the end-to-end solution, usually there is a space for both, like for all approaches, but especially for the audience that we have with public sector, it makes sense where what we want infrastructure and we want more tight control on like that end-to-end system that we are building. So it totally makes sense that we at least have players like you who provide us that option. So that's pretty cool. Yeah, so wanted to, well, one of the questions while you're talking that came up was I see a lot of people ask Sam Altman that, their company kind of eats up a lot of successful ideas that come up like this, right? Like where we will give you a trust score, right? Like what are your thoughts on, like we have the infra, we can build that, and we will provide you an answer and a number, right? Like something like that. So what are your thoughts on that?
That's no problem at all. And the reason, and I say that very like with a lot of lucidity. Imagine that OpenAI releases a score that tells the whole world how bad their models are. Just like play that out in your head for a little bit. And you'll quickly realize that, A, if they did that, that's probably not a good idea because now everyone will know just how bad their stuff is. And by the way, OpenAI is incredible. We have to recognize that they are the company of the century right now. Like that's
Absolutely.
And the same with Anthropic. Like this is like the time to be alive. Like this is an incredible moment, and let's just hope that we can do a good job as a species,
Civilization. Yeah.
And as civil human beings with a commitment to one another. But that's another discussion. But coming back to this idea of like gobbling up the startups, and there's the safety and controls benchmark. I know OpenAI doesn't want to build like a very, complex, rigorous, like as good as network security protocols, safety and reliability system. Like that's just not what that's so far off. Maybe they do it. There's some possibility, but like it's pretty far off. And then on the trustworthiness side, I think it's very unlikely that they will be telling the world how bad all their stuff is, every single output that comes out. And so those are sort of two obvious points. There's a slightly less obvious point, which is if they decided to go that route, I think people might just ask them like, why does your system ever do anything wrong in the first place? Like, if you just think of them as a provider, it makes more sense from a product standpoint to just only produce good answers in the first place and not produce bad answers and tell everyone they're bad. So I just think from a product standpoint, it doesn't make sense. Then finally, there's a compliance and third-party checking regulatory stance.
Absolutely.
Yeah, and so you got it immediately, but
yeah.
But in case someone's listening and they don't, it doesn't quite click. Like I'm from rural Kentucky, so like my background doesn't mean that I wake up and I just can't wait to hear the word regulation and compliance. But like this is a very important thing, and that's that if you are a company like OpenAI and you are also responsible for telling the world how good your stuff is, it's really hard to know what's true because the company that's giving the stuff is also the company that's telling you how good the stuff is.
Yeah.
And we've seen this, by the way, with the end-to-end startup, like there's the Sierras and the Decagons. We have other companies reaching out to us saying, maybe we'll have you build our end-to-end customer support too, but the thing we definitely want you to do is check this other party. Because if for example, if OpenAI or Anthropic or any of these providers also are providing the scores, then the company has no idea how to trust the scores. So you need a third-party provider that can do that compliance and regulation.
Yeah. Yeah, totally. There is this independence of like the person who is doing the compliance and regulation. So it has to be independent person in terms of entity, plus maybe even the way you solve it. Otherwise it's too white box. Like there is a high correlation in what that their solution is saying, plus what that their trust score is saying. Like they're doing it the same way. So doing it an independent way is good from multiple angles. So that totally answers that question. So some questions I wanted to get into that were specific to public sector companies. So one of the things is that there are no clear laws yet about like what needs to be done. One of the things that a lot of public sector companies struggle with. How can a trust score serve as a simple metrics that public sector companies start with, reporting today to show some diligence before legislation lands? Like, do you think that makes sense? Have you seen that work in some settings?
Yeah, so whether it works or not is difficult to say, especially on a podcast, because it's kind of use case specific. But what I can say is that public sector and private sector can help each other here. And a good starting place is the most highly regulated industries like financial compliance, also auditing of financial businesses. These are two areas that you're either interested in it or you're not. I've been in the academic side for a while, so I used to have a deaf ear to these. And then as I've gotten older, I've realized, wow, this stuff really matters. Like
Yeah,
this is the
me too.
delta between getting all my money lost, like when
Totally.
Silicon Valley Bank went under, right? Like all the
Yeah.
investors, I was an investor, like you lose everything. And these are all like little subtle, things. And so then regulation and compliance comes out about the way things are set up, and that stuff really matters. And it affects people in ways that aren't necessarily, it's kind of like sometimes under the scene, but it was what also caused a lot of the housing crisis is poorly applied regulation to like the ways that mortgage stocks were rated, and just a lot of different pushing the bubble of like compliance and regulation. So anyway, over the last 25 years or whatever, and every president, I'll try to avoid the politics, but like different political regimes push a different level of compliance and regulation, and there's deregulation. And I think, at least for me, when I was younger, I like did not understand how impactful all of this is on the bottom line of the average person.
Mm-hmm.
So I guess let me bring it back to the question, which is like, how do we, in the public sector, how do we, use these trust scores and evaluators to be able to serve the population better, if I can word it just a little bit differently?
That's exactly what the question is. Yeah.
And I used all those examples where the public sector got punished because of private sector lack of compliance and regulation. And so my biggest suggestion is like, pay attention to those use cases. Look at the places where compliance and regulation was not as strong as it should be. There were businesses that were lobbying for that to be the case because they're profiting off of it. But look at the impact that it had on people, and you'll recognize that in every single one of those scenarios, at least the ones that are document based, that you could apply an LLM that runs a trust score on every single bit of data that's being processed to determine a single evaluator, which is this sentence here compliant with all the regulations that are required for this type of market or application or use case? And to get really, really fine-grained here, let's just look at one example. Say that, for example, you have an agent and it needs to be compliant with like a federal regulation, say in like the country of Canada, that basically is saying, this agent cannot say anything bad about like an underrepresented population or like a native population, then it's very straightforward to have a trust score that checks every single output out of that agent's mouth, the robot mouth, but that checks every single output and says, look, did this mention, for example, a certain type of population? And if it did, what is the sentiment around that statement? Is a class of words that it shouldn't have used? Is it very, very highly likely to be accurate? Meaning, is the trust score extremely high when it does make such statements? And these are a set of guardrails that are like pretty fundamental to set up. If they're not set up out of the box, then you can end up in a situation where you aren't just, making business faster with AI. You're actually like destabilizing populations and creating like biases and shifting your population to be like potentially a type of cycle mindset that is exactly the opposite of what you're trying to create as a governmental institution or as a federal institution. And all of these things can be controlled. You're not controlling the people, you're controlling the AI that is influencing the people so that it doesn't influence them. So you're setting up controls to prevent creating like an angry or biased population, to just try to make it only say the most boring things. And there's actually a lot of value to doing that. Let the people be creative versus the AI enforcing its creativity on them. So it's just an opinion, of course, but like that's a very clear example of how you can apply these things.
That's pretty. What were some biggest surprises moving from academics to the market?
Yeah, like you mean from going from being, so I thought about being a professor and just the whole academic world, and then to
being like a founder of a company.
Yeah, I mean, I can't do this in a short period of time, so let me try. I'll do an inaccurate version in a short period of time. I think first off, the requirements and demands are very different. You're not able, there's a demand on focus that is through the roof with business that is not, it's not even comparable in academia.
I see.
In business, for example, you need to focus on marketing and product and culture and team and HR, and they're all so different. So they demand such critically different parts of your brain. In academia, you can be ruthlessly focused on a certain part of your brain and be still pretty effective. My PhD advisor at MIT, his name's Isaac Chuang, and he's best known for inventing the quantum computer. And I share that just to give some clout. He's really, I was very lucky to work with him. And he shared something somewhat profound with me where he said, I said to him I was grateful how nice the people were in his lab, and he just immediately shot back at me, and he was like, he named like 4 people down the hall who all were Nobel laureates, and he was like, they're not nice at all. And I that always stuck with me, because in business, being kind is a critical part of building the relationships, and you need to build relationships because that's how you are able to deeply understand their pain. And when you understand their pain, you can then solve their pain and provide value, and that's how the business grows. But in academia, you can actually not really understand anyone's human pain at all and just solve like a critical physics problem and still do like pretty well. So I guess
I see what
I
you're-
just, I'm from MIT, so I'm clearly sharing like a certain, if I was from Stanford, I probably would not have answered that question that way.
Oh, yeah, you need to be more well-rounded, I guess, something like that. Okay, sounds good. Okay, rapid fire to finish. What's one AI fact you hear at conferences that makes you cringe, if there is one?
Oh, I can't stand the recent, everyone keeps saying Andrew Ng said that AI is the new electricity. I love Andrej Karpathy, but the fact that he keeps saying that and quoting Andrew Ng, it's false. And it's Andrej Karpathy, so when he speaks, he's almost always accurate. So people but I object to Andrej Karpathy saying that, because Andrew Ng is just copying Jeff Bezos. So I encourage anyone who doubts this statement to go online and search that the internet is the new electricity, and you will see that Jeff Bezos gave a TED Talk. Like 30 years ago, Jeff Bezos gave a TED Talk where he made this claim, and all Andrew Ng has done is copied that and just replaced internet with AI.
Oh, I see. Okay, I did not know that, and I use that a lot. So I will look this up for sure. Which non-technical skill had unexpectedly helped you as a founder? I think you mentioned already, but
I think I was born with leadership qualities, and that part has been good. I've always had the ability to be very deeply passionate and influence people to solve really hard problems. And I'd say the best way I know to put that is I've worked with a lot of people who weren't quite sure whether or not they wanted to invest deeply in anything, and they were kind of lost. And then after I worked with them for a time, they found a tremendous value in being really focused with me on solving hard problems. And I've been able to put together a lot of teams that on their own were kind of doing whatever, and 1 + 1 + 1 added to 3. But then when we put them together on a very focused problem where it was so critical and it was clear what the guidelines were, it was worth, 100. And I'd say that's probably been the greatest strength. You don't learn any of that in academia, that's for sure.
And if you are not building clean labs, what would you be doing? Would you be a professor? What is something overhyped trend in AI that you think will fizzle out soon, if any?
There's 1,000. I mean, crypto is supposed to make a comeback, and I'd be okay if that fizzled right back out again.
Me too.
There's a bunch of other stuff. I think pretty much anything. You'll notice that like most apps are actually just copy and paste ChatGPT. So like you'll have some software that like is software engineering, then you copy and you paste it in ChatGPT. You take the answer, you post it back, and you call it Cursor. Cursor's a great product, but like, but like I think that is being a little overblown in terms of sort of the insight. Now, as a business, like it's fantastic. There's nothing wrong with the product. It's great. It's a great product. But I just think it's overhyped in terms of like the AI value.
It's a very thin wrapper. I totally agree. Final question. The biggest shift that we will see in AI by 2030, any bold predictions?
Yeah, many. I think customer support is going to be fundamental. Like the vision that like this idea of it used to be a storefront and then it was a website. Like that's a very real thing that happened. Like if you wanted to interact with Walmart, like you can still go to, a storefront, but you also interact with their website, and you do mentally think you're interacting with Walmart when you're on Walmart.com.
Totally. Yeah.
So it's going to happen. It's going to be agents. That's a real thing. And you've probably heard that before, but it's also something I fundamentally believe where some people are sort of shaky, and I feel like 100%.
Absolutely. Yeah. You're right. Some people are shaky, and like Salesforce, for example, has bet big time that that'll happen. And what you're saying is that, you're seeing agents as the front for many businesses, and that's going to become quite prevalent by 2030.
I do. I'll give you one more thing that I think is like a for sure business that's going to happen. I think it may be Cleanlab, like but there will be a day when you can just share all the compliance requirements and they will just be enforced. And there isn't the whole workflow to go from like the document all the way to building all the guardrails. Like the moment that the document is created, AI can take it, perceive it, create the guardrails, and produce the entire infrastructure to be able to maintain and manage it in an observable way. This is something that we're actively working on, but if we're not first to market, somebody will. There's a million things like this, Garesh. Like,
Cool.
it's coming. And there will be a lot of places where AI is not good enough, but there's a lot of places where it is now.
There will be. Okay, that's going to be it. Thank you so much. I always love talking to you, and this was fascinating. I got to know so many stories that I had no idea.
Yeah, you too. It's good to chat with you, Garesh, and
Yeah,
I hope
same
this is
here.
helpful for listeners, and
I'm sure
excited
this is
for
going to
the
be
work we're
very
doing
helpful.
together.
This was govai.fm. Connect with us on LinkedIn, suggest a guest, and stay tuned for real stories from AI in action.